Okay, last time we were talking about inheritance, and in inheritance, how we basically uh, try to create new classes, and those new classes basically make one of the existing class as its base class, also known as the parent class, and it absorbs the functionality of the base class into it. So you don't need to write new code for the stuff which you have already written. um, and I was talking about various types of the inheritance as well, and you can always see that lecture once again. Now let us move uh, to the next thing which I was talking about code, but I realized that I missed one small topic in the last lecture, so let me cover that first. Uh, Although I talked in detail about generalization and specialization, like from the base class to the child class to the further child class and so forth, so on and so forth. From top to bottom, we go from generalization to specialization, and from bottom to top, we go from uh, specialization to generalization, right? This thing I missed. There is in object oriented programming, for that matter, and for object oriented analysis and designs. One thing is object oriented programming, and another thing is object oriented analysis and design. This course we are studying presently, and you will be later during your degree you will be taught this course of object oriented analysis and designs. This is basically sort of, not actually, but sort of software engineering from and designing from the perspective of object oriented. And in this particular analysis and design procedure, you think about things in an object oriented manner, right? So I'm not going to into details of this object oriented analysis and designs, but the thing which is referred to here basically deals with OOAD. So usually we design a solution for a problem using our design skills, design softwares, design tools and technologies, and then we implement those designs using a programming language. So if a design is in an object oriented manner, then it will be implemented in an object oriented language as well, right? So as a computer scientist, we are not restricted to programming only. We have to do a lot of stuff as well, which starts from the requirement gathering and designing and so on and so forth. So to give you an example, for example, if you okay, let me use something different. For example, if you go to an office, and the office deals with admission, right? There is an office, there is a person sitting there, and this person deals with admissions. He's maybe an admission officer of a university, and you are here as a computer scientist, and you say, okay, I want to make a software for you, so that if you want to do your admissions and examination and stuff, if you do it manually, you will your processing speed will be less, efficiency will be less. Why? Okay, then this person tells you about his requirements. Okay, and now I'm going to write those requirements in a notepad file. For example, that guy who was giving requirements says we admit students in BS, let's say we admit students in BS CS, BS, let's say ME, and BS, let's say engineering sciences, right? ES. Okay, and then they say that rather before that he says we admit students in BS and MS programs, and then he says a a BS student is a CS student, and he further says that a BS student is a, let's say, ME student, and he further says that a BS student is a ES student, right? And then he says a student has please don't mind these spellings. A student has let's say a reg number, he has CGPA, he has let's say address, so on and so forth. Okay, now if you see here, these are requirements. Like I have written these requirements for you, but in the real scenario, this guy will be sitting here, and this is his office, right? And this is his, let's say, table, and this is his hot cup of tea which he is taking, and you are here, and you are listening to him, and you have a pad and a pen with you, okay, and you're writing these requirements. Okay, so in a typical requirement gathering exercise, you go to a person or a place for which you have to make a software, and you gather the requirements from the people who work there, and you write them in shape of notes, and you then this things comes into place in the written form, and then the person who is going to design a solution, and if he is designing a solution using object oriented analysis and designs, right, which will be implemented using object oriented programming. Okay, and for the object oriented programming you have C++ as a language which we are studying here, but other object oriented programming are like Java, and C# is also an object oriented programming, and there are many other, so you need to know one and you can switch from one to another. But if you see here, now I will be talking about two types of relationships, right? One is called is a relationship, and other is called has a relationship, right? One is called is a relationship, and other is has a relationship, right? So if you see here, we say a BS student is a CS student, a BS student is a mechanical student, for example, a BS student is a ES, engineering sciences student, right? This we identify in the requirements. And if you see here, it says a student has, okay, I missed it, I'm writing it here. A student has a reg number, a student has a CGPA, a student has an address. So whenever there is a has a relationship, we do what? We make a class. We make a class of the type name student. So we make a class of type student, and whatever is in the has a relationship, these things become member variables of this class. Okay, has a variable shows member variables or members of a class, right? And is a relationship basically shows association between two classes. For example, we have a class, let's say student. Okay, let me clean it. For example, we have a class. Okay, I hope you got the point. That has a relationship shows membership, and is a relationship shows association. For example, we have a class, let's say student, std, and we have a class UG, undergrad student, right? We have a class G for graduate student. We have in undergraduate, we have a class for, let's say, CS student. We have another class of students, let's say ME students, and so on and so forth. Okay, now this is a relationship shows association. So this shows that a BS student is a CS BS student is a CS student. So it means BS यानी कि undergrad student is a CS student. So this is shows association. I have not written it here that a student can be a graduate student or MS student or PhD student, but if that was written, so in that case the student class will become the parent class of undergrad student class. So this is how it's done. Now let me go to the slides. So there has a relationship which basically is for composition, right? Composition means you are composing a variable into a class, and has a relationship basically shows is a relationship basically shows association, right? Composition, this is a class and you are writing members in this class. This is another class and this is another class, and if you are making association, you are linking this class with this class. So usually there are other ways to make association as well, but one of the ways is this. Okay, ये खराब हो गया सारा. One of the way is inheritance, right? So this is something which I missed last time, so I hope you got it. Now coming back to our example which we were doing last time, we made a class point, and point had variables x and y. We made another class 3D point. This is a new class, and this colon and public. I told you that we have to use public, but we are not going to worry about what this public does until we have covered a couple of lectures on inheritance. Then I will be explaining it. And then the name of the parent class, which is the point class. So what happens is that the point class, these two variables will automatically be available here. You don't need to declare these here, these will automatically be available here. But there is a huge issue in this complete program. Can you think about it? Okay, look at it closely. It won't work, right? Okay, let me explain it further. See, point class has x and y, right? 3D point has its own variable z, right? In the 3D point variable, if we see its constructor, we are assigning using x and y. Okay, this class do not have x and y, right? But since point is the base class and point has x and y, so these x and y are basically available here. So this is not wrong, it should be working. And then it is using z, so everything is initialized to 0, so it should work. This is what you must be thinking. But again, there is a serious issue. Think about it. I give you 3 seconds. Okay, I hope you may have thought correctly. See, we have not mentioned any access specifier here. Okay, so since there is no access specifier, by default every member will be private. Okay, now when x and y is private, you cannot access these here, right? Either public or protected variables or functions can be inherited. So this was the mistake. So what's the solution? Instead of having private, we can have protected. We can have the protected access specifier. Excuse me for this writing. And let us now go to the compiler and let us try to code it there, right? Now hash include iStream using namespace std and main return 0 and cout hi, right? inheritance. Now I'm just executing it just to make sure that there is no bug, and there is of course semicolon, I missed it. Okay, now let me make a class. This is a class, let's say. Okay, let me use the same example here. Point, and the point class has its variable, let's say int x, and it should have its constructor. See out. I'm writing a message here, right? Hi, I am in point class. How are you? Okay. Now this is the point class constructor. Let me make another class. Class 3D point. Oh yes, because I was trying to write here like this, but this should give an error because every variable or name should start with a character or underscore. So 3D point. Okay, and now I make its member int, but rather x. It should be x comma y. Okay, and now I make a variable z its own variable, and I should have 3D point constructor as well, and I'm copying and pasting it just to save my time. Hi, I am in 3D class. Just to make it prominent, I'm writing static here. So when it executes, we see static, so we should know that. Otherwise, we will have to read the complete sentence. All right, now I've created a class. Oh, sorry. I've created a class point, and I've created another class 3D point. These are two independent classes. Now I want to make this class child of the, I want to make this class child of this class. Now how will I do that? I'll be writing colon public public, and now here I will be writing name of the base class, parent class, whatever you would like to call it. Now in this way, this class is parent of this class, and all the variables which are non-private will be accessible here automatically. So let us use that as well. For example, I say and let me make a print function as well. And here we will display cout. Let's say x is equal to x, right? X, so it should be on new line, and same goes for y, same goes for z. Y is that right? White. Okay. Now this is how it works, and let us run it, and inshallah it won't work. Okay. Now first issue. Right, if you see, it says point is private. Rather, let me do one thing. First of all, let me compile it without having these inheritance stuff, right? Okay, and I'm executing it now, and it is working perfectly, right? Now what I've done, I've removed it, these commands, and I've made it as a child class, 3D point as a child class of point class. And now when I execute it, it is causing me an error because it says that actually there are two things which got mixed. See here, I have made this class, I have not mentioned any access specifier here, right? So everything has become private, which includes this point constructor as well. So when I make it parent class of this 3D point, it is causing an error. So let me do one thing. I make this x and y, just for the sake of explaining stuff, private. okay, and this public, the constructor, I make it public, right? So let me compile it now, rather run it. Let's see. Now, now what does it say? It says that x is in point class is private. Okay, it is not getting compiled again because it is being inherited somewhere. Now at line number 20, let me again remove the inheritance stuff. Independently point class is there, independently 3D point is there. I have just removed the inheritance stuff. Now I am executing it. Now okay, let me, if since I have removed the inheritance here, I should not be using x and y variables as well because these are not members of the 3D point. Now when I am executing it, it is compiling perfectly fine, but it has the problem with this because I have made the point class as the parent class of 3D point and I am using x and y here. So that is why it is saying that you see this x and y are private. How can you access? So we should mention the access specifier here as protected. Now what happens with if you use protected access specifier? All the protected variables will not be accessible, will not be accessible outside the class. They will only be accessible in the child classes, right? So protected is something between public and private. The thing which is protected is only accessible to child classes, or and maybe their child, further child, grandchilds, but they are not directly accessible outside the class. But and now if I execute it, it should be working, right? But if I use public here as access specifier, and now I'll be executing it, it will be working again. But again, this public is too much of freedom to give, because not only these x and y are accessible in the child class, but they are accessible outside the classes as well, maybe in a function main or some other function. So this too much liberty is not appropriate. Now this is how it works. And let us create an instance of the class. Now I'll be creating instances one by one. For example, let me create an instance of point class, and I say p1. Okay, this is a point class, and you know, as I've created its instance, automatically the point class constructor will be executed. And if you see in the constructor, I'm just displaying this message. So this message should be displayed, right? Let me remove this C outline, and I have not created any other instance, right? And let us execute it, and let us see what happens. Okay, now if you see, point class constructor, the point class instance got created, and the message which we wrote in the class got displayed, which is, hi, I am in point class, how are you, right? Now now let me create an instance of a 3D point, right? Rather, okay, let me remove this instance of point class. I've removed it, right? I'm creating a new instance, 3D point class, and I call it TD, right? Okay, and I'm not doing anything else. I've simply created its instance. Now actually what should happen, okay, what should happen, we have a class point and we have a class 3D 3D point. Now excuse me for my writing today. Now this point class is like this, and this point class is 3D point is like this. Now if I create an instance of this class, let's say I call it P and I call it P3. Now what will happen if you create an instance of point P, and again this class has this class as parent, right? Now if I create an instance of class point, in the memory an instance will be created, and that instance will have x and y as its member, right? And when I create an instance of the 3D point class, what will happen? An instance of the 3D class will be created, and the 3D class has a single variable z as a member, but this class will have another instance within itself that will be basically what? Point. This will be point, and it will be having variable x and y. So this is what happens when you create an instance of the class who has a parent class, and you create instance of the child class. So within that child, an instance of the parent is automatically created, right? So this is what we will be seeing here. Now here at line number 42, I have created an instance of the 3D point class, and that's all, and I'm going to execute it and look at the message which will be displayed on the screen. Oh yes, and then we have an error. Now think about it. What is an error? What is the error? Okay, a simple one. Here if you see in the 3D point class as well, like as long as we do not create instance of 3D point class, it is working fine, right? It will execute. Since in the main we have done nothing, so nothing is being displayed. But as we create an instance of 3D point, it is causing an error. Obviously, if you recall in the lectures which we have in the pre-made portion of this course, you will recall how can we stop a class to be instantiated. And I told you that one of the many ways to do that is to make the constructor of that class private. Now if you see here in the 3D point class, we have not mentioned any access specifier here. So by default everything is private, since this constructor is private as well, and when you create an instance of the class, constructor is called. So since it's private, it won't be called and the instance is not getting created. So the solution to it is that we make the constructor public, and we do not write anything with z, so by default z is private. Now I am executing it, and then you have to keep an eye on what is being displayed on the screen, right? In light of what I explained earlier, that for every instance of a child class, within that child instance of the child class, an instance of the parent class is also created, right? And let us execute it. It will be working now. And if you see, now let me hide it for a while. If you again let me re-emphasize line number 43, only instance of 3D point class is created. And here if you see what you see here, the first message which says I am in point class, then it says I am in 3D point class. And if you see here again, we have created instance of only point class. So this this gives you a clear evidence that for the 3D sorry for the 3D point class, internally it has an instance of the point class, right? Okay, if maybe now here we have a point class and we have a 3D point class, maybe we had another class here somewhere here, let's say class and it says, let's say coordinate, right? And this point class maybe was a child of this coordinate class. Let me make it public coordinate. Now Now in this particular case, if I make an instance of this 3D class, what will happen? First of all, the constructor of this 3D point will be called, right? But it won't get executed. Before executing this, it will be called first, but it won't be executed. Before its execution, it will be executing, it will be going to the constructor of the point class, which is the base class, and further, if this point class had another class, like in this case coordinator, it will go to the coordinator class, and there are no further parents. So first of all, the constructor of this coordinator will be executed, then like the grandfather constructor will be executed, then the father constructor will be executed, and eventually the child constructor will be executed. So I hope you got the point here how this inheritance works. And let me remove this inheritance, and let us execute it again, and let us see that this is how it works. And again, if we remove this line and I make an instance of the class point, point I think be capital, and let me run it. Now this is the point class constructor. Now let us see, okay, and now let us remove this inheritance. I'm removing this inheritance. Since I've removed this inheritance, I can no longer use x and y here, right? And now I create an instance of the 3D point P3, and I'm not doing anything else. And now when I execute it, and now if you see, only the constructor of this class is called. It is not calling the instructor of its parent, because it has no parent at present moment, because we have removed inheritance. So I hope this was clear to you, and let me go to the code again here. Right, so this is the issue with this example. So the solution, as I explained it to you, is that we will be making it here, either public or protected. So in that way it will be executed here, otherwise it won't be accessible here, right? And I've uploaded it on the CMS, so you will be able to go through the slides as well. Now this is the solution where this point class is created. Okay, in the next lecture we will be going through the case study of this point, circle, and a cylinder class, and we'll be going in detail through that. So it is enough for today. Thank you.